For a lot of us, the words math class bring back some not-so-great memories, right? Confusing formulas, that feeling of just being lost. But what if it didn't have to be like that? Today, we're diving into a YouTube video that's seriously changing the game for students on a really tricky topic, real numbers.
Now that is a promise. Can you imagine hearing that when you're struggling? It's a super bold claim from educator Ritik Mishra, but honestly, it sets the stage for what is truly a masterclass in how to teach.
So, what's the secret sauce here? How does he take a subject that so many people find intimidating and just make it click? Well, we're not just going to learn the math today. Nope. We're going to pull back the curtain and break down the method behind the magic. All right, let's dive in.
Every good explanation has to start somewhere. And in math, where you start is absolutely everything. Mishra gets this. He doesn't just throw you into the deep end with complex equations. Instead, he goes all the way back to the absolute fundamentals, the building blocks, to make sure everyone's on the same page. And just look at how simple this is. No confusing jargon, no long paragraphs. He just boils it all down to one single crucial difference. Do you have exactly 2 factors or more than 2? That's it. It's such a clear line in the sand. Anyone can get that.
And bam, right away he flips it back to you. This isn't just him talking at you. It's about getting you to think. This little question is such a classic, powerful move. It makes you stop just listening and actually start participating in your own learning.
And there it is, the aha moment. See, by dealing with this one common trip-up, he's not just giving an answer. He's actually making you remember the definitions he just taught. It's such a smart way to lock in that foundation before we start building on top of it. So, let's see what he builds next.
Okay, so we're moving from the basic building blocks to something that sounds, well, a lot scarier, a theorem. But watch how he frames it. He doesn't present it as some dry, boring rule you have to memorize. He turns it into something cool, like a secret code, a unique key for every number out there. So think of it this way. Every composite number has its own unique fingerprint. The mix of prime numbers that makes up the number 12, that mix only belongs to 12. No other number has it. It's this amazing idea that every number has its own secret identity.
And this is where the big idea becomes a practical tool. He doesn't just tell you the rule. He shows you exactly how to do it, step by step. He's taking this abstract theorem and turning it into a simple, repeatable process. Now it's not just something you know, it's something you can actually do.
Okay, this next part, this is where his whole teaching philosophy really shines. I mean, we've all been there, right? You cram a bunch of formulas for a test, and then poof, they're gone a week later. He's about to show us why that happens and how to stop it.
This is so important. He's basically saying if you only know how to do the calculation, you're just a machine. But if you understand what it is you're actually doing, well, then you become a real problem solver. It's the difference between following a recipe and actually knowing how to cook.
So let's talk HCF, highest common factor. For a second, just forget the method. What does it mean? Okay, say you have the numbers 8 and 12. What's the biggest number that fits perfectly into both of them? Well, 2 works, but is it the highest? 4 also works. Anything bigger? Nope. So 4 is your HCF. See? It's just logic.
And now for its partner, LCM, least common multiple. This time we're looking for the smallest number that both 8 and 12 can fit into. Just think of their multiplication tables. What's the very first number you see on both lists? It's 24, and that's your LCM. It's the first place their paths cross.
And only now, after we totally get what HCF and LCM actually mean, does he introduce the method for finding them. And notice, this isn't just some random rule. It connects right back to that prime code we just learned. Everything is linked together. That foundation we built earlier is paying off big time now.
All right, and here we are, the final boss of every math chapter, the word problem. This is where all the numbers and letters are supposed to apply to the real world. And let's be honest, it's where most of us get stuck.
He's like a mind reader. He knows exactly what everyone is thinking right now. And by just saying it, by acknowledging the single biggest point of confusion, he's basically telling his students, hey, I get it. I know where you're stuck. We're going to solve this together. That's how you get people to lean in and listen.
And this is the golden key. It's such a simple, beautiful question. Instead of getting bogged down in all the words of the problem, he's asking you to just step back and think about one thing, the size of the answer. This is an absolute game changer.
This right here is everything. Think about it. If a problem is about dividing things up into smaller groups,
your answer is going to be smaller, right? So you need a factor. Use HCF. But if the problem is about finding when two things will happen at the same time in the future, your answer is going to be bigger. You need a multiple. Use LCM. It's not about memorizing tricks, it's just pure logic. It turns what feels like a 50-50 guess into a confident, logical choice.
So when you step back and look at the whole thing, what's the secret formula here? It's pretty clear. First, you build a rock-solid foundation. Then you focus on what things actually mean, not just how to calculate them. Third, you show how everything connects, one idea building on the next. And finally, you give people a simple tool, a simple question they can ask to solve even the toughest problems.
And that's really the big question to leave you with, isn't it? What if we approached everything this way? Not just math, but any complex subject. What if learning wasn't about memorizing a long list of disconnected facts, but about weaving together a beautiful network of simple, connected ideas? This isn't just a great math lesson. It's a powerful reminder that how we teach something is just as important as what we teach. That's it for this explainer.